everyone. So today we are going to study about Box-Cox transform and what is the Box-Cox transform and why we use the Box-Cox transform. So the Box-Cox transform is used to transform data, particularly to make it normally distributed. Box-Cox and power transformations are statistical techniques used to transform data, particularly to make it normally distributed or to stabilize variance, often used in a regression analysis and time series analysis. A more general transforming that can be applied to a wider range of data distributions. For example, analyzing the distribution of income, which may have both positive and negative skewness. The Box-Cox transformation is a statistical tool that transforms non-normal or abnormal data into a normal distribution. This transformation can improve the accuracy of predictions made using linear regression. So, these are the three main reasons why we use the Box-Cox transform. Let's see. To stabilize the variance, to improve normality, and to make patterns in the data more easily recognizable. So let's see one by one. Mm, First, to stabilize the variance. Stabilizing variance is essential because it ensures that the results of statistical tests are not influenced by variability in the data. Too much variability can make it difficult to see patterns in the data. We can better understand what's happening in a data set by stabilizing variance. And to improve normality, improving normality is also crucial because many statistical techniques assume that the data is usually distributed. When the data is not normally distributed, those statistical techniques may also not work. By transforming the data into a more normal shape, we can improve the accuracy of our results. And to make patterns in the data more easily recognizable, making patterns in the data more easily recognizable can also be helpful when we are trying to identify relationships between variables or trends over time. By making these patterns easier to see, we can make better decisions about interpreting our data. And this is the formula for Box-Cox transform. By using this formula, we can transform the abnormal or non-normal data into normal distribution. So, but this transformation only works with positive values. Using this formula manually is a very laborious task. Thus, many popular libraries provide these functions. And the lambda function is the transformation parameter chosen to best normalize the data, and y is the original data, and the data must be positive because the Box-Cox transform works with only positive data. So these are the advantages of Box-Cox transformation. Stabilize variance, improve normality, enhances model accuracy, data-driven and flexible transformation. Let's see one by one. Stabilize variance helps reduce heteroscedasticity, which means non-constant variance, which is a common issue in regression models. Makes the residuals more uniform, improving model assumptions. And improve normality, transform skewed data, especially right skewed. The data can be uh, skewed in two types: right skewed and left skewed, to be more normally distributed. Many statistical methods, example like linear regression or ANOVA, assume normality of residuals. And Enhances model accuracy. Linear models and other parametric methods often perform better when assumptions are made, can lead to better parameter estimation and predictive accuracy. Data-driven transformation, unlike ad hoc transformations, example like log or square root, Box-Cox finds the optimal power parameter, which is lambda, from the data. And this is the flexible transformation and easy to reverse. The transformation is invertible, so transform predictions can be converted back to the original scale. Like advantages, there are some limitations or disadvantages of Box-Cox transform. Let's see what are the disadvantages of Box-Cox transform. Require positive data only, can be hard to interrupt, not always effective, sensitive to outliers. The Box-Cox transformation works only for the positive data. It requires strictly positive values. Data containing zeros or negative numbers must be shifted beforehand, which can introduce bias or distort the data's meaning. And it is can be hard to interrupt or not interruptible easily. Transformed values, especially with non-log lambda values, are not intuitive, makes interpretation of coefficients or predictions harder in regression models. And it is not always effective because Box-Cox is useful but not universal. It's a good tool for specific issues in statistical modeling but not a one-size-fits-all solution. Always assess whether your data and modeling goals actually benefit from it. That's why it is not always effective, and it is sensitive to outliers because outliers skew the likelihood function. Box-Cox chooses the best lambda by maximizing the log likelihood of the transformed data under a normal distribution assumption. Outliers distorts this likelihood, leading to a pure choice of lambda, which may not transform the majority of the data well, and distorts the distribution shape. Outliers inflate the variance and skewness of the data. Box-Cox may overcompensate, resulting in a transformation that stretches or compresses parts of the data unnecessarily. For example, take one scenario. Suppose you have income data. Most values are between $20,000 or $100,000, but a few are $1 million. The Box-Cox transform might pick a very small lambda or a log-like function just to handle the high income outliers while distorting the majority distribution. That's why it is sensitive to outliers. So this is all about the Box-Cox transformation. So today we will stop here. Thank you so much.